Alright, so welcome to this class. We are going to be looking at the roster and the set builder notation. Okay, so I talked about these two just a little, okay, when I was introducing the set theory. Okay, so we said we had how many times of representing a set? We said we had three. Okay, so the first one we said was uh, where you are describing a set using words. Okay, we said that was verbal. Okay, verbal description. Okay, and then we also said we had roster form, and then we had what? The set builder. Okay, so most of the questions that will be coming will be based on the roster form and the set builder what notation. So you can either convert your set from the roster form to the set builder, or from the set builder notation to the what? To the roster form. So those are the questions that we are going to be what? Dealing with. Okay, so what did we say this roster form and this set builder notation are? Okay, so we are going to go over them. So let's start with the roster form. Okay, so the roster form is what you guys are used to. Okay, the things that we are doing at grade 12, that's the roster form of representing a set. Okay, so this roster form here is just a method where we list, okay, we list the members of the set. Okay, you list the members of the set. So when you list the members of the set, you are using the roster form, okay, of a set. This is the roster form. So for example, I can say my set A is equals to, okay, and then I put the words, or let me just use numbers. So maybe say 1, 2, 3, 4, 5. Okay, so you can see that I've listed all the elements in this set A. So this listing method is what we call as the roster form. And then when you talk about the set builder, okay, when you talk about the set builder notation, okay, it's a way of describing the set, okay, not really using words, okay, but describing it in a set builder notation. Okay, so for you to understand what a set builder notation, you can say it's simply a method, okay, that lists the rules that determine whether an object or an element is part of the set rather than the actual element. Okay, so in this set builder notation, we are going to be describing a rule that will determine the elements that will be in that set. Okay, so for example, we can convert this same set here. Okay, we can convert this same set A here that we had in roster form, we can convert it to what? To set builder notation. So we can describe this set using a rule. Okay, so we can say set A, okay, is a set of all the x's, okay, and then we say such that x is a member of natural numbers, okay, where this x is less than or equal to 5. Okay, so you can see that from the set builder, we are not specifying the elements that are in that set, but we are describing a rule that will tell us the elements that are in this set. Okay, so someone might be confused because of this, what I've written here. Okay, so x is a member of natural numbers. So from our previous lessons, we said that the set of natural numbers, okay, is a set that contains elements that start from 1, 2, 3, all the way up to what? Positive infinity. This is what we said. Okay, so in short, all the positive whole numbers make the set of the natural numbers. Okay, so we can see that in this set A here, in roster form here, these are just the first 5 elements, okay, of the set of natural numbers. Okay, so how can we describe this set now using a rule? Is what we've done here. We've put that set in set builder what notation. Okay, so depending on what you have here, all these are symbols that you can see in the roster form there. They have a meaning. Okay, so let me explain what they mean in case some of you are confused, so that it will be very easy for us to convert from one form to the other. Okay, so I'm going to write a set here. Let's say we have this set. okay, that is in this form. Maybe I say curly bracket, and then I say x, and then a vertical line there, and then x, and then we say x is a member of maybe natural numbers. Okay, so what do these symbols that I can see here mean? Okay, so each one has a different meaning. So the first bracket here, okay, the first bracket there means the set of. Okay, it means the set of. And then this x here means all x. Okay, or all x's. Okay, and then this vertical line here, okay, means such that. So this is mathematical language, right? Okay, such that. And then the other ones, you know, so this one here is just a set of natural numbers. Okay, and then that e there, we know that it means what? Member of, or belongs to. Okay, so just write member of here. So the way we have it like that, it means it is in set builder notation. So we are going to read this set as set A is a set of all, okay, a set of, let me be using blue. Okay, so set A is a set of all x's such that, okay, this x is a member of what? Natural numbers. So that's how we are going to be interpreting the what? The set builder form. Okay, and remember I said the set builder form just gives us a rule, okay, as to which element will belong to that set. Okay, so for example, this same set that I've written there, it will contain all the elements from 1 all the way up to positive infinity. So if we wrote that set in roster form, okay, it will just be 1, 2, 3, and then you go on until what? Infinity there. So you write 3 dots at the end. Okay, so these 3 dots at the end there, they mean it's an ellipsis. Okay, it's an ellipsis. So ellipsis means there are other elements that are in this set, but we've not written them down. Okay, so that's what these 3 dots mean here. They are not there for decorations, guys. Okay, so anything in math has a meaning. So if you didn't know, that's what they mean. Okay, we call them ellipsis. Okay, so they mean there are other elements in this set, but we've not written them because there are so many numbers in that set. All right, so I've explained what the roster form is. I've also explained what the set builder notation is. Okay, so we can now solve practical questions. Okay, so let's go to practical questions now. So please, if you have any questions, I'm very open to making you understand. Okay, so just unmute yourself and then you can ask your question. Okay, so let's go to the next page here. So we have questions now there. So these are practical exam questions. Okay, so the first one, they are saying represent each of the following set in set builder form. So the first one there, what can we see? Okay, they're saying set A contains 2, 4, 6, 8. So we see that the pattern here will continue to be 10, 12, just like that. Okay, so what do you think this set will look like when we put it in set builder notation? Anyone who has an idea? What do you think the set will look like if we put it in set interval notation? Come on, guys, let's interact. Okay, what will be that set in set builder notation? So we just have to find the rule there that would describe this set. So what rule can we use there to describe the elements that will be in set A? Okay, so set A there is just describing a set of even numbers. Okay, so 2, 4, 6, those are just even numbers. So verbally we can represent this set as a set of even numbers. Okay, but now we want to write it in set builder what? Notation. So we are going to say, okay, this is the first one. We're going to say set A, okay, is a set of all x's, okay, such that just a minute, such that, okay, x is an even number. Okay, so this is one of the ways in which we can represent this set here. Okay, and then we can also represent this set in this form. Okay, so the form in which you represent is not limited to one answer. Okay, you can represent it in a number of ways. Okay, so let's represent it. Okay, so we can also say that this set A is a set of all x's, okay, such that x is equals to 2n, okay, where this n is a member of what? Natural numbers. So remember the natural numbers, okay, remember we said the set of natural numbers. Let me write it on top here. So the set of natural numbers here contains the numbers 1, 2, 3, 4 until positive infinity. Okay, so if we describe set A as this, it will be correct. If we describe it as this, it will also be correct. Okay, so on the second part here, we are saying set A is a set of all x's such that x is equals to 2n, where this n is a member of what? Natural numbers. Okay, so this n here can take the value of what? 1, 2, just like that. So if it takes the value of 1, then our first element in this set will be 2, comma. If it takes the value of 2, our second element here will be 4. If it takes the value of 3, it will be 6. It will take the value of 4, it will be 8, just like that. And that's what we can see in this set there. Okay, so you can describe it in this way or in this way. Both of them are what? Are correct. Okay, so is that clear? We can proceed to the next one.
Sorry, sir, could you please explain on the second one? My network dropped.
Okay, so I was saying the second method there, okay, is exactly, okay, the same as the one that I've written on top there. Okay, but we are just representing it. Um, we are just representing it in a different way. Okay, so for a number to be an even number, okay, then it means there's a 2 involved somewhere there. Okay, so we are going to say this set A is a set of all these x's such that this x is equals to 2n. Where are we putting 2 here so that it becomes an even number? Because in this set we can see all even numbers, right? Okay, and then this n here can take any value as long as it's a what? A natural number. So the natural numbers start from 1, 2, 3, 4, 5, just like that until positive infinity. Okay, so I was saying now this form here is also correct because it describes this x here, okay, as an even number. Okay, so in another way in which you can think of it, if you are representing sets in set builder form, okay, if you are representing sets in set builder form, you can think of it as you are trying to find a formula for the elements that are in this set. Okay, so remember, maybe let me refer them to the sequences. Remember the APGP, okay, those formulas that you are finding in order to describe the APGP. Okay, so it will be a bit similar to that. You're just trying to find a formula that would describe the elements uh, uh, in that set that are in roster form. Okay, now we are putting it in what? Set builder notation. All right, so any questions there? All right, so let's look at the second one there. Okay, so on the second one, anyone who has an idea of how we are going to describe that set? Okay, anyone who has an idea of how we are going to describe that set? Okay, so that set is actually very easy. Okay, I don't know if I've taught you the rational numbers. Okay, Sheba, you have a question?
I just wanted to answer.
Oh, yes, you can answer.
So we can say set B
Mm-hmm.
is a set of x such that x is a member of rational numbers.
Exactly. Okay. So this one here is very simple to represent. So when we talk about rational numbers, guys, these are just numbers that you can present in the form a over b. So in short, numbers that you can represent as a fraction. So when we go to this set here, if we try to find a pattern that they're using from one element to the other, okay, there's no pattern there. Okay, there's no pattern. So you are just going to say b, okay, is a set of all x's such that x is a rational number, okay, such that x is a rational number. But you're not going to end here, because if you say only x is a rational number, okay, it means the whole set of rational numbers. Okay, so you said such that x is a rational number, okay, where this x is a member of, and then you write the same set that you have there. So you're going to say 1 over 3, 1 over 2, 3 over 5, and then 2 over what? 3. So you've represented this set that we have on B here in form of a set builder notation. Okay, so x is a rational number such that x is a member of this set here. All right, so any questions there? Okay, if there are no questions, you can also represent this set in symbol form. So we are going to say this is a set of all x's such that x is a member of, okay, so this rational number here, its symbol is a q, like that. Okay, so we are going to say q, meaning it's a, this x is a member of rational numbers, okay, such that this x is specifically a part of these or the following what rational numbers: 3 over 5 and then 2 over 3. Okay, and then you put your other bracket like that. So that's how we can express those sets in set builder notation. All right, so I hope you guys are understanding. If you have any questions, please feel free to ask. Okay, so I want you guys to learn. Otherwise, I'll go to the next question, which is question 1b. Okay, so we are solving question 1a here. So question 1b, now here we have been given the roster form, and then we are trying to find, I mean, we have been given the set builder notation, and then we are trying to find the roster form. Okay, so how do we find the roster form? We just go and see what the x is defined as in this set. Okay, or it can be m, for example, here. Okay, it can be any letter. Okay, here they can use any letter. Okay, so but the most common one is x, so they can use y, p, m, n, any letter. So don't get confused in case you see a different letter. So they're saying write the following sets in roster form. Okay, so we have to list the element in this set here. Okay, all right, so they're saying set P is a set of all x's such that x is a member of z. So z is a set of which numbers? Hello? Yes? Chiba?
It's a set of integers.
Yes, okay. So the set of integers, if you didn't know it, okay, it's the set that contains all the negative numbers. Let me do this. Okay, so you start with the ellipsis, and then you can say minus 3, minus 2, minus 1, 0, 1, 2, 3, and then another ellipsis like that. So you see that here it continues until to minus infinity. Even there it continues until to positive infinity. Okay, so the set of integers is the set of all the negative and positive numbers, okay, but removing all the fractions, and then you are including what? A zero there. So this is the set of all integers. So we're being told here that this set P is a set of uh, all x's such that this x is an integer, okay, and this x is between 2 and what? 5. So it's, if it's between 2 and 5, okay, so it means that the elements in set P, we're going to say number 1. So the elements in set P will just be, we are going to start at 2, so it will be 2, 3, 4, 5, Okay, I think we end on 5 there. Okay, so these are the elements that are going to be in set P. Okay, 2, 3, 4, and 5. Okay, so we're able to list those elements there because we are considering a set of what? Integers. If we had a set of if we had a set of real numbers here, it means we can't list the elements in this set. Okay, but because it's a set of integers, we can list them. Okay, because if you consider the set of real numbers there, it will include the fractions, so meaning the numbers that are between 2 and 5 will be endless. Okay, we have the 2.1 there, 4.9, 4.991, 3.4. Okay, it will be endless, but because we are considering the set of integers, it means we can list this set. Okay, so that set P there will just be this set that contains 2, 3, 4, and 5. All right, so any questions there before we go to the next one? All right, so let's solve the other one then, if there are no questions. Okay, so B, our part 2 there, it's very simple. Okay, so we are saying set Q is a set of all m's such that this m is a letter in the word, this word here. Okay, I don't know how to pronounce that word, but we can see that word, right? Okay, so how are we going to express this set in roster form? Okay, we're just going to say this is the set. Okay, and then we are going to list all the letters in this set, making sure that we do not repeat any letter that appears twice. Okay, so I'm going to say zero. I'm going to say O there is a part of that. I can also see S. I can also see T. I can see E. Okay, I can see A. I can see R. I can see H. And I can see what? I. Okay, so this is the set in roster form. Okay, so this is um, in terms of set builder, and then this one here is set of roster form. So you notice that for all those data that are appearing twice, I'm just writing them once here. So 1, 2, we have 2s there, but here I've just written 1. We have about 3t, 1, 2, 3, but here I've just written 1. Okay, so make sure that any letter that is repeating, you're just writing it what? Once. So the set Q will just be this set here. All right, so any questions there, guys? Any questions? Okay, no questions. All right, so let's proceed. So that's it about the roster and um, the set builder notation. Okay, so now let's use this information of the roster and the set builder to answer the following questions that I'm going to show you. Okay, so the first question is here. Okay, so they're saying with only one of singleton, empty, infinite, classify the following sets and give a reason. Okay, so we have some of the sets there that are in set builder notation, and we have some sets there that are in roster form. So we have to classify those sets if they are one, a singleton set, or they are empty, or they are infinite. Okay, so the first one, they're saying set X is a set of all the x's such that x is between -2 and 0, where this x is a natural number. Okay, so where can we classify this set? Is it a singleton set? Is it empty? Is it infinite? Anyone who can try? When you give us your answer, you even explain why you think so. Okay, so how are you going to classify the first set there? Okay, you can go on.
I think this set is an empty set because if you look at the intervals here, we have -2, which is less than x. You also have less than 0, and x is a member of natural natural numbers. But when you look at this set, we know that this we have integers here, so it can't qualify to be a member of natural numbers. So that's why we're saying it's an empty set.
Okay, yeah, so excellent. Okay, so we see a contrast here because here we've been told that x is a natural number, and I've told you what natural numbers are. Okay, the numbers 1, 2, and 2 positive infinity. Okay, so we have two contrasting scenarios here. We have x is a natural number, and again x is between -2 and 0. Okay, so there is no natural number that is between -2 and 0. Natural numbers start from 1. So we are going to classify this set as an empty set. Okay, this will be an empty set. And then 2 there, they are saying y is a set of all x's such that x is an even number and x is also prime. Okay, so we know that an even number should be in the form of 2n. Okay, so 2, 4, 6, 8, 10, 12, those are even numbers. And then if a certain number, let's say x, is a prime number, okay, then we know that it should have two factors, itself and 1. Okay, so examples of prime numbers, we have 2, 3, 5, 7, 11, 13, okay, and so on. So these are examples of prime numbers. Okay, and then let's write even numbers on top here. So we have 2, 4, 6, 8, 10, 12, until forever. Okay, so here they are saying x is an even number and x is also a prime number. So we are finding a number, okay, that should be in the set of even numbers and should also be in the set of what? Prime numbers. So that number is only 1. Okay, as we can see from the list that I've given here. Okay, so we only have one number which is prime and it's also even. It's just the 2 there. Okay, so the 2 is prime and it's also even. So it means this set y here is going to contain only 2. Okay, and remember when we're defining a set, we said any set that has one element is called a singleton set. Okay, so it has no partner, it's single. Okay, yeah, so that's a singleton set. Okay, and then let's look at the third one. Okay, so the third one is easy to tell because I explained what those 3 dots are. Okay, I said if you have 3 dots in a set, what do they mean? Okay, they just mean that the set goes on, okay, until positive infinity or until negative infinity. Okay, it has no end. Okay, so this one here, just by looking at these 1, 2, 3 dots, okay, we can say that this one here is an infinite set. Okay, we cannot list all the elements in that set. Okay, right, so that's an infinite set. And then the last one there, they're saying the set of, okay, so this is 4. They're saying the set of all straight lines that are parallel to the y-axis on the xy plane there. Okay, so how many lines are parallel to the y-axis? Okay, so let me draw an axis here. So if for example I have this as my axis, this is my y, okay, and then I also have my x like that. Okay, so let's say that this is my y-axis, so I'm going to write y, and then this is here my x. Okay, so they are saying this set here is a set of all lines that are parallel to the y-axis. Okay, so if they're parallel to the y-axis, it means they are going in the same direction as the y-axis, right? So we can draw any line there. Okay, we can draw any line there. Let me get a straight line here. Okay, so we can draw any line on this xy plane. Okay, so if I draw a line here, that would be one line that is parallel to the y. If I draw another one, that would be the second line. If I draw another one, that would be the third one. If I draw another one, that would be the fourth one. Okay, so you can draw as many lines as you want, and all these lines here will be parallel to the what? To the y-axis. Okay, so we see that there's an an infinite number of lines that will be parallel to the what? To the to this y-axis. Okay, so how can we consider that set? We see that that set will just be what? An infinite set. Okay, why? Because we have a lot of lines that are parallel to the what? To the y-axis. So we are going to classify this last set here as an infinite set. Okay, so we've used the set builder notation and the roster form, okay, to identify these sets. All right, so any questions, guys? Any questions that you may have that you need clarity on? All right, so if there are no questions, okay, that's it for today's lesson. Okay, so we've learned the roster and the set builder notation. Okay, so for any questions, always feel free to contact me. Okay, I'll always help you. I want you guys to pass. All right, so I have an assignment for you as always, because I believe you need to practice to understand these things. Okay, so this is the assignment there. You can take a screenshot, but I'm going to send the picture in the group. Okay, so you can try out these questions, okay, on your own. You see if you've understood whatever I was explaining today here. So thank you for watching this video. If you'd like to access the full-length video of this tutorial sheet, please feel free to register with us. So in this video, I'm going to show you how you can register for our lessons. Okay, so what you need to do is open your browser. It can be Google Chrome, Samsung browser, or any other browser that you are using, and then you type in DISCRETE learning, okay, discretelearning.com. Right, so once you type in, you click enter or search, and then it will load and it will take you to this login page. So if you have an account, just go straight in and log in. Okay, if you do not, you need to create an account. So I'll click create an account. Okay, so create an account, and then this here will pop up. So you put your names there. So I am Poul Solutions, and then here you put in your email. Okay, and then here you put the password that you want. So I'll put 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can put any password that you want there. Here you're going to type your phone number. Okay, and then here you put your date of birth. So I was born on 6th February 2025. Okay, so you can put any date of birth there. And then here you are going to select your university. Okay, so we have a lot of university here. You can see there's Gonza, CBU, Mulungushi, Cavendish, all these universities. Okay, so you click the university that you belong to. Okay, so for example, I'm going to click University of Lusaka. Okay, and then you click register. Okay, so it's going to load and it's going to tell you that you have successfully created your account. So what you need to do now is put in the details that you registered with. So you put in your email here that you used, and then there you're going to put in the password that you set, and then you click login. All right, so once you log in here, it will take you to this dashboard. Okay, so this dashboard here, okay, let's remove this. So this dashboard here has all the courses that we offer. So there's chemistry, math, physics, biology. Okay, if you're taking linear algebra, you can register, introduction to real analysis, all that. Okay, so let's say, for example, you want to register for mathematics. So what are you going to do? Okay, you're going to click open. Okay, so you can see they're saying you're not enrolled in this course. So what you need to do is click subscribe. Okay, and then it will bring all the courses that we offer. So you tick the one that you want. So maybe I want to register for mathematics, okay, and chemistry. And then on the right here, you choose the duration. Okay, so I'm going to say math 1 month, even the chemistry 1 month. Okay, let me even put physics and biology here. So I'm registering for those 4 courses. So once you click, once you select the courses, you're going to click enroll. Okay, you wait for it to load. It will take you to this page that will show you the total amount that you're going to pay, okay, for all those courses that you've selected. Okay, and then you click pay. All right, so you're going to have this drop down that is going to come. Okay, so here you put the phone number that you're going to use to pay. Okay, you put the phone number that you're going to use to pay. If you are paying using maybe a mobile money agent, okay, tell them to put their number here. Okay, and then you click pay now. Okay, so it's going to load. So you wait for it, and then it's going to take you to this page. Okay, so here it's telling you about to pay DISCRETE Learning Institute the sum of whatever they are. Okay, so what are you going to do here? You are going to click pay. So once you click that pay, okay, this page here is going to pop up. Okay, so once this page pops up on your phone or your PC, okay, you are going to receive a pop-up message on your phone telling you to import the password for your mobile money. Okay, so once you import the password for your mobile money, you will be able to be let into the website. Okay, it means you have registered. Okay, so let's say for example, let me put in my password on my phone now. Okay. Okay, so when you come back to the dashboard, you are going to see that now you are enrolled in math, chemistry, physics, and biology there. Okay, so allow me to explain some of the things that you can see here. So on this menu here, if you click that menu, the menu will disappear. If you click it again, it will appear. So on the menu there, we have this where it's written learn. Okay, so when you click on learn, you're going to find all the courses that you are registered in. Okay, and then you can close that. You can click YouTube channels. You're going to find our YouTube channels there. Okay, so you can click maybe Tutor Poul Solutions. Okay, you're going to go to my channel here, and then you can watch some of the videos. Okay, it will ask you to subscribe, so you subscribe. So it will show you some of the videos that I've uploaded on my YouTube channel. Okay, but on the website we have a lot of them. So I'm going to show you how you can access all that. So let's go back here. All right, so on my YouTube channel, you mostly find math and chemistry, and then for Tutor John, okay, for Tutor John, you're going to find biology and physics, and then for math with Marius, of course, you're just going to find math. Okay, so I can close that, and then I open this one for study materials. So when I click on study materials there, it's going to take me to this page where we have different study materials based on your university. So if you're from Apex, you open the Apex folder. If you're from Unilus, you open the Unilus folder. Then you open that just like that. If you're from UNZA, you open the one for what? For UNZA. Right, so let's go back there and then check what we have inside the courses there. So we have talked about all these here, okay, on the menu. So if, for example, you want to learn something, okay, you just open, okay, this course, and then you're going to, if you open math, you're going to find general mathematics and probability and statistics for second semester Apex. So this one here is specifically for those who are doing second semester Apex. Okay, for the rest of you, you just go in the general mathematics. Okay, so you're going to find 4 folders there. One will be for the lessons and tutorials. The other one will be for the handwritten notes. The other one will be for the tutorial sheet and assignments. The other one will be for what? Past quiz, tests, and exam papers. Okay, so the setup is the same. Even if you go in the chemistry folder, the biology folder, the physics folder, any folder that you go into, you're going to find the same. So if you go in lessons and tutorials here, okay, you're going to find all the topics that you can have in math. So you can see there are a lot of topics, right? So let's say, for example, I want to learn maybe SADs and rationalization. So I'll click SADs and rationalization there, and then I'm going to find 3 folders. Okay, so the first one is for the notes. The second one is for the recorded tutorials that we record for ourselves. And then here where I put supplementary tutorials, okay, there are other videos that you can use to learn. So if I click on slides and notes here, you see you are going to find the notes here. So you can click any to study them. Okay, let's click this one here. All right, so the notes are going to open like that. Okay, so they have opened there, so you can go there and you can study them. Okay, so these are your notes to study, so make sure you study them. They are very simple and simplified. Okay, so what if I leave these notes? Okay, I also have these notes here that I wrote by myself. So we can go through these notes to learn. Okay, so if you don't want to read the notes, you want the videos, you go in the recorded tutorials. Okay, so you click there, you're going to find the videos here. So there's intro to SADs, whatever I can see there. Okay, so let's play the introduction to SADs. So you click on it, it's going to open like that if you're using a PC, so you can move a bit up like that, and then you play it. Okay, so you can start learning here. Okay, you can start learning. You can see the video is playing. If you want to fast forward, you just click on these 2 things here that are on the screen. So you can double click on them. You'll be fast forwarding your video. And then at the end here, okay, at the end here, I have these 2 icons here. Okay, so the last one there puts you in full screen mode. So if I click it like that, my video is going to appear in full screen mode like that. Okay, so you can watch your video in full screen mode like that. Okay, if you don't want the screen mode, the full screen mode, you can still watch. That's the way it is there. Okay, so we also have this icon here. So this icon is for picture in picture play. Okay, so you can play your video while doing something else on your PC. So if you click on it, you see I'm going to have this a small thing popping up there. So even this is on your phone. So you can be playing your video there, and then you can even leave this browser. Okay, so you can even go somewhere else. Okay, like this. So you see it's still there. Okay, so you can play it, and then to return to full screen mode, you just click on it, and then you'll be able to return to the full screen mode here. All right, so that's it on the lessons and tutorials. The setup is the same in all these topics that you can see. So you just pick the topic that you want to learn, and then you'll be able to learn. All right, so after that, you can check out the handwritten notes. Okay, so these handwritten notes, most of them have a password. Okay, so the password is PB4511. Okay, so you can open the ones for set, you find them, okay, you study them just like that. So these are very good notes. They are very simplified. So make sure you use them. All right, so those are the handwritten notes. And then when I go to the tutorial sheet and assignments here, I'm going to find different universities. Okay, so if you're from Apex, you go in the Apex, you open, you're going to find video and written solutions. So the video solutions you open there, you're going to find, depending on your intake. So this was for the January 2024 intake. This was for the 2024 July. And then for your intake, which is 25 this year, you place there. Okay, so you see the videos that we've solved so far there. Okay, so you can open them if you want to learn. So it will come, you can play it, and you'll be able to learn there. Okay, and then what else? Okay, you can also check out the written solutions here. You're going to find some of the written solutions that we upload there. All right, so if you do not see your university here, you can go in this folder where we wrote our tutorial sheet and explained solutions. Okay, so you open this folder, you're going to find a lot of tutorial sheet based on all the math topics, okay, that you can have. So these tutorial sheet here have solutions. So for example, if you want to learn functions, okay, if you want to learn functions, you just have to open this folder here. Okay, just have to learn open this folder. Okay, let me say I want to open the one for the logs and the exponentials. So you click on it. So it's going to open here. Okay, so you have the questions here. Okay, so you can take note of the questions that you have and then try to solve them. And then once you are done, go below the questions there. You're going to find the solutions. So these are the solutions there. Okay, these are the solutions there. So you can learn using them. Okay, so you can go back there. And then if you are taking a stats and probability, we have some tutorial sheet here. So you can open and then you can check them out. Okay, we also have more worksheets on the probability and statistics. You can check them out there. All right, so we are done with the tutorial sheet folder. Okay, so you just go to your university there. And then when you go to the past quiz, test, and exam papers, you're going to find a similar setup, okay, to the tutorial sheet folder. So if you're from Apex, you go to Apex. If you're from Unilus, you go to Unilus. If you're from Mukuba, you go to Mukuba. So for example, if I go to Mukuba here, I'm going to find video solutions, okay? You can see the video solutions for some revision of their test papers. And then even you can even go in the written solutions there. You're also going to find the written solutions. Okay, and then here we have some past papers on probability and statistics. All right, so that's how you can use this drive. Okay, so feel free to try out whatever you want. Okay, so search for whatever you want on this drive. You're going to find them. Okay, even in the chemistry there, if you open, it will be a similar setup, general chemistry for the rest of you. Okay, and then if you're doing second semester Apex, you go in this folder here. Okay, so let's try to go in the general chemistry there. You're going to see the setup is the same. Okay, so if I go tutorial sheet maybe, and then I open the folder for UNZA, okay, you're going to see video and written. Let's try to open the written ones. You're going to see the tutorial sheet for the chemistry that they take at UNZA. So you can open any. Okay, you can open that. You find all these tutorial sheets that are solved. Okay, you can open this folder. You find all these tutorial sheets that are solved. So make sure you use what is on the drive. Okay, so our Learning Institute, okay, is the best because you can learn at any time, anywhere, okay? You don't wait for us to teach you. You can actually teach yourself, okay? But we also have live classes. So when you register, you have two types of classes that you're going to be attending, okay? One is the live classes where we interact and you can ask questions. And then the other one are the recorded classes that you find on this website. All right, so that's all about this website. Feel free to register yourself and then start learning, okay? Thank you so much.